In this lesson, we're going to use our newfound calculator skills to do some function analysis. So function analysis was the big focus of a past unit, right, where you figure out if a function is increasing or decreasing on certain intervals, where it has relative minimums and maximums, and the function's concavity, so whether the function opens up or opens down, and where it goes from concave up to concave down. You do have this in your notes, but I'm going to put it here again. Make sure if for whatever reason you don't have notes on this, you capture this somewhere. You're probably, hopefully you're getting to the point where you have this memorized at this point in your calculus career. These definitions are probably one of the most important things. Like if you memorize nothing else from AP Calc and you're planning to take Calc in the future, this would be good stuff to memorize. So the first derivative describes whether the function is increasing or decreasing and where it has minimums and maximums. The second derivative describes where the function is concave up and concave down, and an inflection point is where it changes from one to the other. So we're going to need these facts as we tackle doing this with the calculator. So the calculator doesn't do all the work for you. It just does a lot of the work for you, but you still need to know things in order to use it intelligently. So let's take a look at a problem here. Here we go. So we have a function f, and we're given the second derivative of f. So we're given f double prime, and we want to find the intervals in the given domain. So the given domain is from negative 1.5 to 2.5, where the function is concave up. Okay. So the first thing we're going to do is we're going to make a note of what we're looking for. So concave up means we want the second derivative to be positive, so bigger than 0. So that is what we want. And then we're going to tackle this graphically. So we're going to type in this function into the grapher on our calculator. Okay, so I've typed it in exactly as I see it. And I already double checked that I'm on radians mode. And then I want to look at the graph of this. So f double prime bigger than 0, that means our graph is going to be above the x-axis. Okay, so we're going to take a look at the graph and figure out where the graph is above the x-axis. But remember that we are only interested in the real results on a certain interval. Okay, so what I'm going to do to make this super clear is I'm going to change my graphing settings so that I'm only looking at that interval. So I'm going to go Window, and you guys I'm sure have seen this previously in your math career. I'm going to adjust this so I'm only looking at this interval. So from negative 1.5, there we go. I really wanted it to be on the left side of my screen for some reason. From negative 1.5 is what I want my window to be for my x. So x min is negative 1.5. X max is going to be 2.5. And then I don't have to think about whether I'm inside the interval that I want or not, because the only values on the graph are the ones that are inside the interval. My y's, I'll just leave the same for now. So if it looks like my graph is going outside of my window, I might want to adjust those and come back. But I'm going to leave them the same and see what I get. So I'm going to hit graph, and it's looking nice, right, as I graph it. So if, for example, this went way up here and got cut off, I would want to adjust. Okay, so what I see here is there is some piece of the graph where my function is positive, my second derivative is positive, but I'm not sure where that interval is. Well, you may already know how to do this. What we're going to do is we're going to use the 0 function to figure out where those are at. So I'm going to hit second calc, and then 2 or 0. And I'm sure you've done this before. So left bound, I go somewhere to the left of where I'm interested in. Doesn't matter where. This is just telling your calculator where it'll look. So visually you're like, the 0's here, I'm going to go somewhere to the left of it. Enter. Right bound, I'm going to go anywhere to the right of the first 0. Right, so I want to go between the two. We're going to do this twice, and we want it to look specifically for the left one first. Hit enter. And then it's going to be like guess, and you're going to hit enter again. You're going to be like yes, guess. Okay. And there is the first 0. And we're going to do 3 decimal places again because it tells us to, and also that's what you're going to do in the AP exam. 0.310 we're going to round this to. So that's the first x in our interval. And then we're going to do it again. So same thing, second calc 0, because we want the other bound now. And now left bound, I'm going to go between the two. Enter. Right bound, I'm going to go to the right of my 0. Enter. Guess. You're going to be like yes. And you're going to get 1.494 is how you're going to round that. So this is our concave up interval, so where the graph is above the x-axis. Okay, so you could have, I guess you could not have done this one by hand, right? Because you don't necessarily know how to solve this algebraically. But you know already these facts, and you are the one doing the interpretation. The calculator is just helping you with the algebra. So these are concave up intervals. Now, I could have asked you for a concave down interval, and that would be everything else. So looking at my graph again, it would be these pieces where the function is below the x-axis. So I would say, remember we're starting at negative 1.5, so my concave down intervals would be from negative 1.5, or 0.310, and, or sometimes you do, right, 1.494 to 2.5. So you still have to be smart about what it's asking and decide which part of the graph you're looking at, but the calculator helps you find the bounds. So here's another problem where we're going to have to do the thinking. The calculator is going to help us as a tool to figure out these values. So we want now where f has an inflection point. So recall that our inflection point is where f double prime is equal to 0 and changes signs. Right? Notice though we're given f prime. So here's where we're going to use that derivative function this time. So this is cool. So if I want to go from the first derivative to the second derivative, I'm just going to go math 8, the derivative function again. I'm going to stick that right in the graph right here. So I'm going to take the derivative with respect to x, and then I'm going to type in my function. So I've typed it in. If you're typing it in along with me, which I suggest, double check that you did it accurately. And then the last question, and here's why you realize why this calculator costs so much money and why we make you buy it. The last question is like x equals. I'm going to be clever here. I'm going to say I want this. I want the derivative of this function for all x. So I'm going to type in x again. So x equals x. And when I hit graph now, what it's graphing is actually the derivative of this. And that's why it goes a little bit slower, because it's actually doing a little bit of work to figure out what the derivative looks like. Now I haven't changed my window yet. I'm going to change it to the domain that's given. Although we can already see there's a couple of inflection points here. So I'm going to change it to -2 and 2.5, and I'll leave my y's alone unless I need to zoom out. I'm going to hit graph, and we have 2 it looks like. So I'm going to do the same thing as I did before. So second calc 0, left bound, right bound, so we'll pick one. We'll start with the right one. Enter, enter, enter again. And we'll round to 3 decimal points. So I'm going to say that that is at x equals 1.300. And you can just write 1.3 in the AP exam. You would not lose points for that, right? The other one And you can check by using the zero function again in your calculator. It ends up being the negative of this guy. So those are our inflection points. Okay, so obviously calculator is a super powerful tool. In these problems, you still have to do the work of figuring out what it's asking for and making sure your calculator is spitting out the right thing for you. So you're in charge of interpretation, your calculator is in charge of doing the math.